So I'm going to run through the tutorial data files that I made available during the second statistics practical workshop. So I'm going to start with the lung cancer file, which is this one. So this is an example of categorical data analysis. It's analysis of qualitative data when you can just count up how many things you have in different categories. This is the actual lung cancer data set that was used by Richard Dole to show there is a link between smoking and lung cancer. I've simplified it a bit. He had a more complicated one, which we'll come to a bit later. So this is an example of data which only has two variables, and it has two choices in each of the two variables. So this is a standard epidemiological table. So if I go and have a look for epidemiology in Google, and I put it into Google, and I then go down to Wikipedia and I just scan down a little bit. So the basic model in epidemiology in a case control study, is this one. So you have exposure to some factor that you think causes a disease, and then you have those that have it and those that don't. Then you have these other things. So these are odds ratios and chances. So an odds ratio of 1 to 1 is where you're equally likely to be in the cases as the controls, whether you're exposed and unexposed. But usually you find out that there's a difference in the odds ratio. So if it's greater than 1, you're more likely to have the disease because of the exposure. If it's less than 1, you're less likely to have the disease because of the exposure. So this is the general thing. The rows are the causative thing, the exposure that you're subjected to, and the disease state is the columns. That general epidemiological model that we're going to look at. So it says this contains the data. So now I'm going to do an analysis of it, and it's going to produce a 2 by 2 table, a 2 by 2 contingency table. Now it's important that this is 2 rows and 2 columns because there are some special properties of that kind of data. So let's do the analysis. So you go to Analyze, Descriptive Statistics, Cross Tabulation. Now, as I said, smoking goes in the rows because it's the cause. Cancer status goes in the columns. Both of them are yes and no. Then you click on the statistics part in the right hand menu and you pick chi-squared. You can also pick risk here, which will calculate the relative risk and the odds ratio. So I'll click that on as well, press continue and press OK. And this is the output. So the first thing is just telling you what SPSS has done. It's found 2,714 cases, processed all of them. This is the usual summary table that you see. So if you're a non-smoker, your chances of not having cancer, you've got 152 are non-cancer, 56 people have got cancer. For smokers, it's 1,205 people have not got cancer, 1,301 have got cancer. This is a case control study where you've gone and found people who have cancer in the hospital and also found matched patients that don't. Now the hypothesis that you're testing is there a difference in the probability of getting cancer when you're a smoker or a non-smoker? Is the likelihood the same in both groups? Is the odds ratio 1? If that was true, amongst the non-smokers, you'd expect to have the same amount in the no's as yeses, and in the smokers, the same amount in the no's and the yeses. So here you can see in total 1,357 in both of the yes and no in the cancer and non-cancer, but they're not evenly spread as ratios between the non-smokers and the smokers. That's what the chi-squared test is predicting. So when it calculates it calculates a test statistic. So the test statistic is this thing. So it's the actual observed count minus what you expected. So they expected for this row, you'd add the 152 to the 56 and then divide by 2. You'd expect them both to have the same amount. And the same here, you'd add the 1205 and the 1301, which is the 2506. Then you divide that by 2 to figure out how many you'd expect to find in each. So then you add up the total for those 4 cells of what you actually see minus what you expected to see. That value squared, add them all together, and it gives you the chi-squared value. You then calculate the p-value. P-value is less than 0.001, so that means it's significant. So you cannot say that you're equally likely to get cancer if you're a non-smoker as a smoker. The next thing you can look at is the odds ratio. So the odds ratio tells you how many times more likely, what are the increased odds of you getting cancer for being a smoker compared to a non-smoker. And the increased odds are 2.931. So you're 2.931 times more likely to get cancer than by being a smoker than a non-smoker. And that is all you need to do looking at the first data set.